In today's video, we're going to be making some of these. So today's job is to modify a few of these. These go to a 1937 Studebaker President, and they hold some part of the spare tire carrier. I'm not sure because mine's not a state president. These are for some club members. I believe one guy's in Romania, and the other one's from my buddy Sergio. So this has to be drilled out, and there's a divot that has to go here. This has to be threaded, and then we've got to drill a hole here. You can see how difficult these will be to hold, but I've got it figured out. The other thing is we've got to shorten up a few of these threaded screws, if you want to call them that, and we've got to put a slot in. You can see here my friend had done these and he didn't feel comfortable with that and was doing some of the other work, and so he asked me if I could take a look at it. So I think what we're going to do here is run a slitting saw across that. You maybe can see that I've got a slitting saw already set up in here. I've also got to put a divot in these. You can see where he started, and it didn't want to center itself, so we're going to do a little bit more with that on the lathe to keep that centralized. So meet me over at the lathe, and let's get on with the job. Alright, so here's the one finished one that he sent me. I'm trying to get this close enough to the camera that you can see it, and then see there's a little slot on the other side. That looks really simple, but I can assure you it's not so simple. Because if you look at how something's got to go in the jaws on the chuck, if you put something that's threaded in there, what does that do to your threads? Squish, and then you've got a dent in 3 places on here, so we can't do that. So what I've come up with is this. This gives the jaws somewhere to grab, it gives it a stop, and once I put it in the vise, I can, I'm talking on the mill, once I put it in the vise on the mill, I can take it and flip it this way and then run the slitting saw across it. So that works out pretty well. Now I thought maybe I'd show you the blueprints. So this is what we're after, and this gives us all the locations, the hole sizes, all that jazz. We don't really need it because I'm going to be measuring off the original to try and make them all match, but if we get lost, here we go. Here's our drawing. It's always good to follow drawings. I think what we're going to have to do is maybe take and clean the bottoms of these up because they're cut kind of jagged where they cut them off the sprues. If you don't know what a sprue is something that comes in like this. So if you had your piece and you're casting it, and you're feeding that bronze or brass or steel or whatever in, that sprue is like a runner. So they cast it in wax, there's a shell around it, you cook the wax out, and then it leaves an open passageway. So I'll show you. So if you look at the bottom of this one, that one you can see they just had to cut it off with a saw or something just to try and get it to work. But I'm not going to be responsible for cleaning these up. I think he's going to do that, but he's just marked it out so we know. This one's not too bad, but I may just clean that up a little bit too. Looks like they've just run a belt sander across it. I don't think it's very critical, but we may be able to do the same thing. Get this flattened out so we can locate properly off of this. Because indicating these is going to be a little bit fun based on the fact that there's not a lot of flat areas in here aside from inside here, and those aren't really flat either, but we don't want that tipped. So let's get this taken out of here. We'll do the next one off camera. I'm sure you guys can see how that works, or maybe you can't. I don't know. All right, so on this one you can see that the end of this is kind of not formed very well, and the cut in the center doesn't look very good. I've measured the overall length on this. We've got to take stuff off the back edge too, but I think that we can clean all this up and the back edge and still have enough. I'm just going to feed this in by hand, make sure I'm not going to break this tool off, because this is an interrupted cut here. So I've got that slot.
Yeah, I don't like the way that sounds.
We're gonna try it. Nice if I could get underneath that all in one cut, but I don't know. As you can see, this is quite a bit smaller than the nuts that I'm using to hold this. So just see if that'll go on there. If it doesn't, you know, we can always hit it with a file real quick, but yeah, it's giving us problems here. The other thing is, when we take these off, it's going to chase those threads. So it's not overly important. I just wanted to see if it would go. It almost does. Holds it. So we've got all of these done. I've got one over here ready to be slit in the slitting saw. So why don't we move over there, and I'm going to go ahead and clean the camera lens in the meantime, because now I'm noticing it's smudged. So that turned out pretty good. There's a little bit of scraping and stuff on here. We'll clean that up afterwards and put that on the surface grinder and just make it look nice. Sweet. Okay, well, kind of figured that was going to happen. Okay, so this is our tester. I goofed up last night. You probably saw me using the slitting saw. I knew that was a chance that it might break, but wow, did it ever break. Anyway, I'm going to include that in the video because I screw up all the time. And that's fine, because I actually had an idea to use a die grinder cutting disc, and the problem I was having was this arbor is junk, and I had to modify it. And it was already kind of screwed up, and it wasn't running true, and I had to modify it to take the slitting saws, and they're Harbor Freight slitting saws that aren't meant for this. I knew that, right? So I went down and got new arbors, and these will actually fit in my collets. The collet grabs that nice and tight. If the GoPro will show it, this is my third cut with that, and that cut looks just fantastic. It's nice and clean. I can easily control the depth off of my touch off, and then just run the table in about 20 thousandths at a time. I'm going for 45 thousandths total depth, and the profile looks good. Alright, here's my setup. I'm just going to use a spotting drill to get this to the right depth, and then this doesn't have to be super accurate. So what I'm going to do is, I've got this indicated on the 1-inch line on the tailstock. I'm just going to hold up this caliper, and once that 1-inch line gets to the far side of the calipers on this edge, then we should be good to go. Now we're going to hit it with this tool right here and kind of scoop it out a little bit more, and then the last step is to hit it with this burr grinder bit. There we are. So that should be 80 thousandths right there. Looks pretty decent. I hope this isn't boring to you guys, but you know, not every job's exciting. This is what I've got to do on a daily basis, so you guys are along for the ride, whether you like it or not. All we're trying to do here is take out the bulk of the material. bit of chatter going on there. Okay. I can feel like hit the bottom. Oil on here. I don't want to have this flinging everywhere. And it kind of makes it hard to see what I'm doing. I've got to drill here and divot here, and then obviously drill this and tap it, and that's got to be tapped as well. And if you guys noticed my hokey setup before, that is because this thing is a piece of junk. I do have other chucks, some really nice ones. But if you look in here, you can see what my problem is. I need to shorten this, and even at that, I'll have to turn this down and make this so it fits in a collet. Alright, so these turned out pretty good, as you can see. I did end up putting a little bit of cutting oil on there to smooth out the cut, and they turned out nice. I don't think the customer's going to have any complaints about these. And I wish I could hold them all together so you can see them together, but you know, hopefully that's not too wide, but we shall see. Mistakes. Also, there's a piece of our slitting saw. So that was lots of fun when that came apart. Take 3,000. So I think we're going to call this good for tonight. I'm going to go and have some dinner, and we will finish this up tomorrow and get this customer his parts out and get them shipped off. Alright, it's the next day. We've got this end mill set up in here. We're just going to clean up the end of this one, probably just this one brass piece, and get that a little bit more flat. So let's hope we don't screw this up. Like I said, these are cast parts, that's why I'm saying close as I can, because there's no true reference surface on anything on this, and these are not engine parts or anything like that. So let's get on to the next thing. Okay, so what I did is just put this tap into the drill chuck, and then I'm just turning this up top. Okay, and I'll just undo this from the chuck. Okay, we are having one hell of a time with this tap. I had to switch taps. So, let's hope this one goes through without breaking off inside here. This whole job's been this way. I thought that was taking it down with the chuck, and it wasn't. It was just sitting there spinning in place. But luckily it didn't damage it, otherwise I'd have to weld it up. Man, I'm done with this job. It's like the boogeyman's in the shop. Alright, despite all the problems here, that turned out looking nice. Alright, well, this is our redneck setup, but it is pretty dang rigid, and it will conform to the contour of the part. Now I need to indicate this and make sure that this is straight up and down according to the part that we milled. This is part of the reason I milled that. But this is how we're going to do it, and the nice thing is I can kind of see through here a little bit. Okay, well here's what we came up with. This is our little setup to test how this is tipped, and I don't know if you can see the dial on there, but I'm going to roll this back. And if you look on there, we've got about, we get to the far edge, I want to let that button come off, we got about 15 thousandths difference. Alright, I think we got it within half a thousandth. I don't know if you can see the dial indicator here, but we're going to roll the table, and we're going to go this way. So look for that to move. I'm seeing about a half a thousandth, which is way closer than we need to be, but I'll take it. Oh, you're off of the part. You went the wrong way. Go back the other way. That button goes up on there. Okay, keep going. Keep going. Keep going. Yeah, I'm getting about a half a thousandth, so I would call that good. It took a while to figure out how to set up an indicator. I finally got this little Kent Moore set up on here, and alright guys, so I wanted to make sure that we had everything located properly. So what I did was I measured out my distances, measured the width of my hole, all that, and if you hold it up to there, it looks pretty dang good. And I came up with the idea of putting a Sharpie in here before I start drilling, and I can run that down and make a little dimple on there. Marks that piece non-destructively. I don't know if you can even see that, but that allows me to make sure this is on. And then I measured my distance from front to back on this, and what I did was I measured the width of this piece here, so the edge of this, and then I measured my hole and divided the hole in half. So I added half the hole to the edge of this, the entire width of this skinny piece right there at the front. And I come in here, marked across that, and look what we have. We have a little scrape line right across the center of my Sharpie mark. So we got it first try. Okay, that's moving around a bit in there. We need to be real careful here. So I just went ahead and drilled as deep as I could with the spotting drill, and I noticed something, and that is this is actually clamped securely, and it was before. I'm not sure how much benefit that C-clamp gave us, but all the flex is coming from here on up. There's nothing I can do about that other than be careful so we don't snap this off. I don't think that would happen, but still, I mean, that thing's in there pretty good. Okay, power she blows. Looks good. Yeah, that looks really good. If you look right there, it looks really centered. If I put my face on the edge of here and align it to center, that looks great. Okay, so I'm going to go ahead and enlarge this with a proper drill for this little screw that we've got to put in here, and then go ahead and bring it back when I'm threading it. But you can see that worked out really well. My biggest problem is going to be finding short drill bits to go in here, but we'll keep this one on hand.
because that sucker's nice and sharp, and it did a great job after we spotted it.
In place and uncheck that a little bit and see how far we can slide it down. Okay, that's just about it right there. I don't think that's going to make it. Now this presents me with a real moral dilemma here, because I could probably take this whole thing out and dimple this with a longer drill bit outside of this. It'd probably be fine. But I'd like to thread this while it's inside the machine so I can get that tap straight, because that looks really good right now. Let's just feed down and see where we're gonna get. Oh yeah, that's gonna make it. Look at that. Going to be where the screw comes through, and it's dimpled on the inside, so it'll squeeze down on the rod or whatever's in there, the door hinge pin. But that looks really good right there, and we'll finish this out with the ball end mill and make that a little bit more round. It'd be nice if I had a ball end mill we could just fish up through here that was that long, but he'd probably get a lot of chatter and run out. So let's go ahead and get this drill bit out here and start tapping it. Alright guys, this turned out really good. Even the divot in there, that drill bit has a pretty rounded profile to the end of it. And that did great. I'm not sure I want to even mess with that any further. And of course now the heater turns on. Look at that. I chased this again with the tap just to clean it out because there were some shavings in there. And I can screw this down with one hand. So that really worked out well. So we're going to move on to the next three. All right, so we had to come up with a solution for this. So I made this little tool and built this so that we've got a little flat here and a grub screw, and then I ground a flat spot on this burr grinder bit on the surface grinder and slid it inside there, and then that keeps that tensioned. And then that allows me a little bit of flexibility to go around and grind this and get that kind of wallowed out to where we need it. So basically what I can do is I can set this in here, and I can move it around kind of like this in a circle and get these ground, and then I'll just take out that grub screw to get this unhooked. So you can see the flat I've ground on there, and that just stops it from rotating. That grub screw grabs onto that, and then it stops it from being able to spin there. It may not have even been necessary, but it's good insurance. So I'm going to go ahead and do the rest of these off camera. You've seen how they've been done, and there's nothing really new to show you there. Hopefully you enjoyed this machining content and maybe you learned something, and I know I definitely did. And this really required a lot of problem solving because I've been sick for 2 weeks and this was a real grind to get this done. But we're there. I've got 2 more to kind of wallow out, and well, 3 more. And we will be finished with this job when we get it sent out. Like, comment, subscribe. We're really picking up speed here with the subscribers. I really appreciate that. And if you'd smash the like button, that really helps too. It bumps us up in the feed so that you can see the new videos and other people can too. This is Reaper, signing off on another one.